It's my great pleasure to introduce Professor Andrew Steane, our very own Professor of Physics.
Thanks. My contribution should last 10 minutes or less, and it's intended to be, as it says in the programme, a sort of reflection stroke synopsis. So my way of interpreting that sort of task is to say I will, some of the time, try to say in my words what it is I think I heard. And then the relevant speaker can tell me, no, you got that wrong, or not. But often, in fact, for communication between people, it is actually quite valuable for person A to say something, person B to say back what they think it was, and then, you know, we can see where we've got clarity. But of course, I will also introduce a few thoughts of my own, and I'll occasionally pose a question which people might want to reply to. So if we come first to Professor George Ellis, I should say. I've, in each case, given a brief reminder of what the sort of subject was. I've not copied the title, but broadly, George Ellis was talking about four categories of causation characterise why specific things happen. I've read a few of Professor Ellis's papers, and I want to just remind people, or reassure people perhaps, that when he talks about top-down causation, most of what he's wanting to say there is simply to re-emphasise a standard part of the way we understand science. I say most of what he's doing with that phrase is simply reminding us that boundary conditions, are part of what is needed to be talked about in order to understand any physical configuration. And he wants us to see that they are central to the account and ought not to be seen as just an afterthought. Now, he also goes towards emphasising a stochastic element in physical behaviour. And not that he said so today, but I know from his work that he's interested in, for example, the use of the stochastic trajectory way of formulating what we mean by a density matrix in quantum physics. So the density matrix can be reproduced mathematically as a summary of a set of trajectories, and each one of which might involve random processes. And I think what I want to say, and George will tell us if I'm wrong about his thoughts, but clearly this is a way of seeing it. Many people would want to say, well, if quantum field theory, so the underlying theory, does not agree with that stochastic jump way of thinking about the density matrix, then so much the worse for quantum field theory. Okay, so the point is that quantum field theory doesn't necessarily win all these battles about different ways of looking at a given physical theory. He emphasises the idea of causation as driven in a downward way, enabled in an upward way. So it's the idea that the macrophysics is still important, but what it does is provide an enabling framework for what then goes on. And of course the causal closure only when all levels are taken into account. So he's saying quantum field theory on its own does not present such a causal closure. I have to say I agree, but what does it matter what I think? Okay. Professor Koons, options for a quantum hylomorphism, which is something to do with pluralism, I understand. I'm not familiar with the term hylomorphism, but I think I've learned today what it is a bit. I felt that he did a good job of setting out issues which I am aware of, issues surrounding how to interpret quantum physics, the measurement problem, and all those things. Interestingly, the notion of stochastic behaviour came up again. If there are fundamental laws governing composite objects, how can this be possible in view of the fact that we think there are macroscopic laws? How can they be both? And he offers that maybe it's because there's a stochastic nature which leaves room for further types of law, or it could be that quantum mechanics is itself only approximate, or that it has limited applicability. I think my job as a physicist here, who knows a lot about quantum mechanics, is to say, yeah, all of those are entirely plausible. None should be just rejected out of hand. I would just say, though, coming now to Boudewijn, which came up in the discussion, those accounts do struggle very hard to formulate a convincing relativistic quantum field theory. So I think that Boudewijn, worthy though it is not seen by many physicists and philosophers for this reason to be a real contender. It just is too hard to get quantum field theory, relativistic and so on, out of that approach. And then on the point 5, is the dynamic law of quantum mechanics grounded, or how it is, if it is grounded, how? So I heard from Robert something about the Aristotle, can't pronounce that word, use of the idea of the essence of the substance may give a grounding, and I was trying to ask myself, what are you really saying there? How would I evaluate the correctness of any answer you might give on that? So I don't know what to make of that. Yeah, I'm going to go for too long. Tell me how much I've got long. I'm going to have to join this.
Another few minutes.
Yeah, okay. So, yeah, here I just want to make a point of my own. The question about, is the physical world itself as a whole isolated? Well, I just want to say that quantum physics can't give answers to questions of that kind. And I want to just suggest that what we can reasonably expect from quantum physics is guidance on how parts of the physical world influence one another. Let's let that sink in. It sort of goes against the idea that there's a universal wave function which we are all sort of trying to figure out and then interpret. It says, no, that isn't necessarily the way to see what quantum physics is about. I found Hans Halvorson's interjections very helpful to, who's brave enough to disagree as well as, and thank people. Yeah, and George said some interesting things about Hamiltonian and Hilbert space, but I'll move on. Okay. From Alyssa Nay, so, excuse me if I'm mispronouncing. Yeah, I found that was interesting and thought-provoking, but for me, it seemed to me that the three-dimensional space-time perspective, which you sort of end up trying to recapture, seems to me, well, surely that's the explanatory one. Yeah, you're sort of putting the cart before the horse, it seemed to me. I want to add that, for me, a ket is mathematically correctly said to be a vector in Hilbert space. But from a physical point of view, I think it's somewhat of a mistake to use the word state to refer to this ket. A ket is a tool in search of a job. There is no wave function of the universe, or at least that phrase is like talking about the velocity of the universe, or the mass of the universe. These are highly questionable concepts. Yeah, anyway, we can discuss that further if you would like. From Emily Qureshi-Hurst, I found that to be fascinating. I found the lefty-righty discussion helpful to really make us think about questions of human identity and exactly what would a variety of people have to offer on this. I love the foregrounding of the plight of the individual sufferer. I hate the idea that we talk about these grand principles as if somehow we can just ignore what would follow for human experience if what we were saying would be true. I think we mustn't lose track of what we are really saying. And for me, I have to say, by all means, come back to me, but I really struggle to find any clothing on the Everettian emperor. Okay, the goal is to get physicists to think more broadly. That came up in discussion. That's a good goal, I think, of these things. To get the physicists and others who talk about these things to really connect what they're saying about science to what they're saying about the rest of human experience. Yeah, so Philip's talk again, clear, fascinating. I wondered whether the argument about reason and physicality is like the one championed by C.S. Lewis, and of course he's not the only one to have put it. You can tell me later, or in the discussion. That argument which he makes was also, counter-argued by Van Inwagen and I dare say others. I'd be just interested to know how all these things talk to one another. And then coming to Timothy O'Connor, Weak and Strong Emotions, really clear talk, really helpful to me for that reason. I like the thought that ultimately I learned about the notion that how strong emergence, as he put it, sort of bootstraps the ontological significance of the weak version of emergence. And I confirm, as was already confirmed for George Ellis, yes indeed, energy conservation is not universally applicable in physics, important the concept though it is, it's not universally useful. And I think what contemporary physics has to offer about things like the strong emergence picture is neither this is right nor this is wrong, but rather, yes, it is open to us to think that way, to say strong emergence is how I think is really happening. Physics, as we have it so far, is unable to either, give you a reason to say a definite no or a definite yes to that. I'd like to also hear from others about the arguments from John Lucas and Roger Penrose concerning whether, in fact, human mathematical reasoning exceeds what a Turing machine could do. This seems to be very close to some of the things that were being talked about. And then this final talk. So I'll say briefly, I think what I got from Daniel to Haan, I agreed with what came up in discussion, but much of the time I was thinking, okay, that is what is going on in science, but I'm not sure quite what is the disputed point you want to arrive at. But I think we then got there in the discussion afterwards. Yeah, I made a few notes to myself on this, but I think I'll leave it there because I think that's more fresh in all of our minds, and I should stop there. So, thanks very much.
Thank you very much, Andrew. Now, I'm not because the panel is a full 25% of us, and we have a boundary condition of 5:45. I'm not going to allow the panel to get into a. No, I didn't mean to say that. I meant this. What I'm going to do instead is to ask the panelists, not in any order, to contribute a very, very short thought for the day, something they've learned, something they really disagree with, or something they're pondering. I'll go first. I was very relieved by the short exchange between George and Timothy O'Connor about strong emergence being diachronic, because I've been worrying about that for the last few weeks, and it put my mind to rest. So thank you for that point. A thought for the day, please. Who would like to go first? Andrew's already given his.
Well, one thought I think that occurred to me was that the question, Andrew actually touched on this, the question of the nature and status of laws of nature is really central to a lot of these other disputes about physicalism and emergence and so on. I think. My guess is that those who take laws of nature to be the absolute bottom line, which don't need any kind of grounding, as we say in metaphysics, that working now? I'm speaking something wrong.
We'll keep going on.
Yeah, all right. Are perhaps more inclined then to a reductionist or to a physicalist kind of story, whereas if you take, as I do, the idea that you have to talk about causal powers and essences of things, and the laws of nature then are just a sort of summary of the way things are naturally going to interact with each other, that actually pushes you in some way out of the direction, gives you some grounds to take powers at these composite levels and other kind of levels more seriously. Okay.
George, are you next?
Yeah, I think so. Where I agree with Robert, he had various options in there, and I think for me the key thing, if I had to say one thing what I'm saying, is that I believe that quantum mechanics has limited applicability. And if you try to understand real systems, real quantum chemistry is applied to molecules as they're changing their shape and so on, you find always that you actually have to use classical concepts in order to apply the quantum physics. You can't apply quantum physics to everything because then nothing is there that you can hang on to. And that's even the double slit experiment. You can't say that the slits are quantum because you have to describe them classical. So I think the use of quantum theory is actually, it's incredibly important, of course, but you have to ask yourself all the time, what's the domain within which it's applicable?
Does any of the other... Oh, Philip, please.
I always instinctively like to think about methodology. You know, we've got a debate here. It seems to be the central debate is like, are middle-sized objects fundamental in some sense? In this conference, most people are on board with that. Saying philosophy more generally, probably the more reductionist story that maybe Alyssa's sympathetic to is more dominant. But how do we settle this? You know, do we need to think ordinary objects exist at all? If we do, what is required for them to exist? Could it exist if there's just particles arranged in a certain way, or the wave function behaving in a certain way? You know, how are we deciding this? And the way I like to think of it, just to give my own answer, that it wasn't what I was talking about, but I guess kind of Cartesian and epistemologically at least, I think the evidential starting point for me is we have the conscious experience as we do, and so we need a theory of reality that can account for us having the kind of conscious experiences we have over time. And if we can do that without there being middle-sized objects, great. You know, if we can't, so that's the thing we really know to be real. I'm not just about solving the hard problem. I mean, like, to account for the regularity, and yeah, that's how I would say, that's like what I would judge this all on. But anyway, maybe people have different methodological views.
Alyssa, were you...
I guess I wanted to agree with, in the last session at the end, Robert, you said something like, we shouldn't just take this, we shouldn't just think it's like a priori settled that all of these objects can be understood physically. I think that's right, and I think that in general, yeah, I don't know what the percentage of philosophers in full survey said they were physicalists, but I would guess it's a very high percentage.
52%.
Really? That low?
Well, 52% for pro-physicalist, 32% against. The others don't like the question. It's not quite Brexit. 52%.
Okay, I'm surprised it's that low. But, okay, well, in any case, I think it's interesting that it's, well, I thought it was a more dominant position than that, but there's no good argument for physicalism. It seems like the only argument for physicalism that is supposedly, I don't know, that isn't like clearly wrong is a causal argument, but almost every physicalist is a non-reductive physicalist, so they have to reject. It seems like, so, yeah, it's very puzzling to me. I think we have to be clear about like why we're making this assumption. And I mean, I do make it, and I think it's just because it's been very successful for us, but to say that it's a priori or there's some good argument for physicalism, I think is, yeah, it's just not correct. So, yeah.
I've been around longer than you, and I've seen a lot of failures of physicalism over the years, so I'm less impressed by its success, to be honest.
Two other people left. Would you like to offer anything?
Well, I also found Tim's claims about how the weak emergence was coming out of the strong emergence, and that was sort of like a priority approach. And then also, I like Philip's argument about some of the functionalist accounts and how it's sort of missing out. The inverted pleasure-pain account, I really liked that sort of argument in particular, so I found that really helpful.
Well, I noticed that our two scientists here on the panel represented what I most often hear among physicists when I hear them talk on these questions, which is a certain modesty about theoretical frameworks and just how far they can be extended. And there's a bit of a contrast with the philosophy of physics crowd, who tend to make very strong claims about a kind of universal framework.
The Haans is an exception.
Yeah. Hans is an exception on the one side, Sean Carroll's an exception on the other side. Yeah.
Sorry, I can't count. 3 people left.
So mine's just a kind of broad and general thought, but I really appreciated just seeing a snapshot of how much disagreement there was about what is fundamental matter, consciousness, middle-sized beings. And I think a meeting like this, which is interdisciplinary, is so helpful. And I think actually, if we don't all talk to each other from these different disciplines, we're not going to come to an answer. Maybe we might not anyway. But I think talking to each other is the best way to get there.
Thank you. So let's throw things open. So I'd be interested to hear any thoughts for the day that everyone at the other 75% has, or any questions for the day to any particular members. I think Howard, you had your hand up first.
Right. I think this is relevant. Daniel Haan was the only person who mentioned Cartwright's philosophy of science and the dappled view of the world. But I get the impression from hieromorphists, even though they don't always bring it in, that really it's lying behind a lot of their thinking. So how many of the people who are sympathetic to hieromorphism on the panel will say, yeah, that's probably more or less the right view of science, all the sciences are, yeah, okay. And whether they think it's an essential part, a necessary thing, in order to get the Aristotelian picture going.
That's a hard question. I would say almost necessary.
That was an almost necessary. Sorry, we have the.
Well, because of the prestige of science, and I think she's one of the scholars of science who does really support the kind of modesty that Tim was talking about, right? That the laws of nature are always contextual; they're applied in particular situations, and this tendency we have in philosophy to extract the mathematical formula and say that's the most fundamental thing in the world and that's what controls everything, is something that she's pushing back on very effectively and looking at how science is actually practiced.
In the connection to holomorphism?
The holomorphism? Yeah, so
that's what he was saying.
Right, oh yeah, right, sorry. Yeah, so that's a good question. So it has
Can
to do
you,
with the
can you hear at the
pluralism
back? Sorry.
process. I think holomorphism is all about a plurality of different kinds of substances and parts of substances at different scales. And so it fits very nicely with Cartwright's pluralistic sort of approach to sciences, where, again, particle physics is not the absolute monarch in the picture. Neither is it in mine.
Can I bring things into that?
Yeah.
I mean, I would be inclined, if what the physicists at this conference are saying, like George, that we have absolutely no reason from physics to think there's no strong emergence, then I don't think we need the kind of Cartwright view. But then I think, listen, you say you're sympathetic to David Papineau, thinks, no, we do have good scientific reason to think there's no strong emergence. Then maybe you need to bring something like Cartwright to say, no, you've got the wrong idea about science. And I don't know how to sound like I'm not a scientist, but it seems to be different scientists say different things about whether science gives us empirical grounds for doubting strong emergence. And if it doesn't, then I would say we don't necessarily need the Cartwright type view.
And George, on the dappled world.
Just a comment, you must be careful which scientists. The scientists from fundamental physics whose whole focus is on particle collisions are a very different crowd from the people who work in condensed matter physics and deal with actual real emergence. It's the latter people who deal with emergence, and those are the ones you must listen to.
I have found that talking to different scientists.
I'd just like to recommend anyone who wants to think, bring Nancy Cartwright and Dappled World into, the discussion. Don't forget to read the review of her book by Philip Anderson. It's quite a critical review. He thinks she, strongly underestimates the sophistication of what the physicists like him and others really think about and do. So just read the review and that will...
It's an absolutely scathing review. I was reading it last week. He accuses her of not understanding science. But, yeah.
It's helpful for understanding Cartwright, that review as well. It's sometimes a bit tricky to read.
Any other members of the panel coming in on Dappled World? No? Okay, there was another question at the back. Yeah.
So I think this is most naturally directed at Dan, who's maybe the most vociferous in favour of the medium-sized objects. So, but I was wondering generally whether we could shed light on the question by extending the concept, metaphorically, towards the mathematical. So we might think that the number one is comparable to, say, a chair has a similar relation, and maybe the power set, the empty set, is something like a discovery of fundamental physics. And so might we have the same worries about reduction as we maybe have about reducing personal agency to something physical, when we talk about or reducing the natural numbers to set theory.
Please with some last answer, because I didn't understand the question.
I think
unless you can ask it again.
I'm guessing, is that a question about reducibility in mathematics compared with natural sciences? Is that
something like that? So the typical set theoretic reconstruction of arithmetic, I guess, is what comes to mind there. Right. Gosh, I don't know. I'm not thinking about that. My first initial reaction is those are really quite different things. Very different things. But
it does get back to Wigner and the unreasonable effectiveness question again, as nearly everything does, in my opinion.
Can I just weigh in on that?
Rabbit, yes.
Dissertation is on this. That is that people like Aquinas will say that to recognize anything, you need form, and just that one is not a number; it's a principle of number. So if I ask you how many Hubble bulbs are in this room, the first thing you need to know is what is a Hubble bulb, right? And so in order for you to count, you need to know what the thing is. So of similarity and difference. And the set theoretic reconstruction of natural numbers, I think, is highly abstract and a very different way of getting at things that you can get more naturally through form and matter versus trying to counts. So I do think that there is a parallel there, but it's perhaps not obvious to everybody.
Yeah, I know there's some interesting work being done in there in Aristotle's philosophy of mathematics.
Anyone else on the panel? Okay, I think several hands up now. I think that you were probably earlier. Yeah?
Yeah, it's just on the mathematics thing. So one big difference in mathematical reductions is typically the problem is that there's too many ways to do it that all work. Whereas in physicalistic reductions, the doubt is that there's any way of doing it, even in principle. So that seems to be pretty stark.
And I think you had a question as well, didn't you?
Yeah. So I just want to share the. I agree. There's interesting way of thinking that consciousness of Philip's way of thinking that consciousness is a type of hard data that we all experience it, and we have to take it into account of our worldview. But at the same time, when I think why physicists are more skeptical about such arguments, I would say, is that science has taught us that a lot of statements that we think are true, like by our intuition, eventually turned out to be false somehow. I mean all the special relativity or general relativity or the quantum theory, at least in certain interpretations of it, I think physics as well as mathematics in certain way, informal way, showed us that intuition is not always a good, advisor on what is true and what's not true. So I think why physicists could have some problems with this accepting substances of middle-sized matters. I mean, I'm opposed to being too skeptical, but at the same time, some skepticism I think is appropriate because the intuition could lead us away. Would you agree?
Perhaps Philip and Timothy could both comment on that.
I guess I just think Descartes got something right when he says the thing we're most certain of is our own conscious experience. All you can ever do, how do we know anything? How do we know we're not in the matrix? I don't know. All you can do is start with what seems most evident. And I would say the reality of our own experience and maybe some mathematical truths are more evident than anything else. And therefore they ought to have. I mean, it doesn't mean we're not confused about some things, or some of our intuitions about consciousness may be wrong, but I suppose how I would characterize the data is very quickly, if I think about I'm feeling pain and I attend to my pain, I think I'm feeling like that. I think I know we're pretty close to certainty that.
But I also feel that times have, the way the times goes by is constant. Yeah, I have the feeling like this, but eventually it is true that when you move, your clocks click in a different place.
Yeah, but then we don't have that same kind of Cartesian certainty about the reality. There's how time feels and how it really is a separate thing, but how pain feels and how it really is, so yeah. I mean, I'm not saying. I guess if there was some strong empirical reason to doubt my view of consciousness, maybe there'd be a difficult tussle there. I suppose I don't think there are such reasons, but I certainly think the reality of consciousness should be given a hell of a lot of weight.
I think we get into problems with the use of intuition when we extend it beyond its natural, reliable limits, right? So on analogy to sense perception, it's pretty good about discerning the properties of middle-sized objects within this room. When I look up at the sun or the moon and naively estimate how far away it is, we get into trouble. It's just not meant. So similarly, you might say, yeah, if I try to take intuitions about how middle-sized objects tend to work, certain kind of proto-physics type assumptions, and I insist on foisting that on the quantum level, then I'm going to get into trouble. But intuitions about middle-sized objects and how they behave, we need to believe that there's some measure of reliability, right? Just to get, for science to get off the ground. I know what I'm looking at when I'm, you know, consulting a measuring device and so on. So there's a tricky balance there.
Okay. Would any other panelists like to, oh, Alyssa, yeah? No, would any other panelists like to come in on this? Otherwise, Richard has a question next. No? Okay, Richard, go ahead.
In all these discussions about the reduction to the physical, no one's given a definition of the physical so far, and it's often not given in books which write about these matters. They're apt to say, well, physics is anything rather like our current physics, but of course what counts as rather like? My own view is that the way to carve up the world along the joints is to say there are two categories of things, substances, properties, events and so on, those to which there is public access and those to which one person has privileged access. Anything that physics deals with, anything any future physics will deal with, will be a public thing in the sense that any physicist, duly equipped with the right apparatus and so on, will be able to find out about it as well as anyone else can. Whereas, when we are in pain or have a thought crossing our mind or form an intention, yes, other people can make a quite good guess at what we are feeling or doing on the basis of our behaviour. But of course we could use that as evidence if we wanted to about what we are thinking and doing, but we have an additional means of knowing about it, that we're actually experiencing it. And that there's two categories of things and they fall apart like that. And the one is clearly different from the other because the one entails the non-existence of the one. Something being physical entails that it's not being mental in this sense.
So physicalism, is it related to physics? I'd love to hear from a physicalist and a physicist on this one. I think, Alyssa, would you like to take this?
Yeah, but you stack the deck with a bunch of physicists that aren't physicalists.
So the issue is not about physics is at the moment, but what any future physics or past physics would be like.
But I don't have like a, I think, I don't have a very standard view about this. I mean, I think it's right, you can't give an a priori definition of the physical. I mean, you can give an a priori definition of the physical if you like the way you just did, and then that's going to be important for you to kind of describe your metaphysics. For me, I'm interested in the question about how far we can go in explaining things in terms of quantum mechanics and other things. I don't think it's analytic that we can. I just think that's like a worthy enterprise, and I think that's what most physicalists are doing. So for me, the idea is we're talking about current physics. So I'm not, as a physicalist, I'm not trying to claim that there is some physical theory in the future that we can imagine that's complete, because I agree with you, there's no kind of way of giving an a priori definition of what would be like a future theory that is still close enough to physics. I think the interesting physicalist position is that the theories that we have right now, quantum theories like general relativity, like proposed extensions of those, are have the resources to explain things like consciousness and agency and chemistry and all of these other things. So I think physicalism is really only an interesting position if it's about our actual current physical theories that have been formulated and empirically supported. If we're just talking about speculative theories, I mean, we're not talking about anything that's ever been empirically supported, or we even know what we're talking about. But I'm just one physicalist, and I do not have a mainstream interpretation of that position. So.
Thank you. So we have 1 minute left. Can we hear from a physicist? We have to, I know George would you like to be the last person to speak, George?
I want to offer two resources to this group for people who want to know about strong emergence in physics. The first is Philip Anderson's famous paper, More is Different. If you haven't read it, you should read that one. But the one which is more important is Bob Laughlin's Nobel lecture. And he talks about supersymmetry, about superfluidity, and it's a superb statement on the nature of strong emergence, the inevitability of strong emergence in physics, and he discovered the fractional quantum Hall effect, which is a wonderful example of strong emergence in physics.
Can I add something on that? It is quite important.
30 seconds.
Just, I emailed at great length who you just mentioned, and we're back to this issue that it really wasn't clear whether he was talking about weak or strong emergence, which is what came up last time. Can I just say, should we name a pub for those not going to Edensong as well?
Let's not. If you want to do that out there and collect them in the quad, but we're gonna lose time.
We need to finish, so please can we show our appreciation. Thank you, everyone.